Welcome back, chemists. This is our second lecture on matter. This one is entitled Properties of Matter. In this lecture, we're going to be talking about the physical and chemical properties of matter and how that is attributed to substances at the molecular and atomic level. We're going to talk about how a physical and chemical property, how they are different from each other, and how physical and chemical changes are different from each other. And we're going to look at two examples of how you can separate a mixture based on the properties of the molecules in it. So first we need to talk about what the identity means to a substance. So this is what a substance is known as. For example, water is known as water, or H2O. Gold is known, its identity is gold. What determines the identity of a substance is the atoms and the bonds between atoms that make that substance. So if we change the atoms and the bonds in the substance, that is going to change the identity of the substance. A property is a characteristic that describes the substance. So for example, water is the identity. Flammable is not a property of water. Water does not catch on fire. Water is not shiny. Water is not magnetic. Those are not properties of water. However, if we're talking about gold, gold is shiny. So properties are characteristics that describe the substance. They're kind of like adjectives. And the arrangement of the atoms and bonds in the substance also determine its properties. So when you change the arrangement of the atoms and the bonds, it will change the properties. And it may or may not change the identity, depending on how the atoms and bonds are changed. There are two types of properties that we're going to learn about in this lecture. The first is a chemical property. The second is a physical property. A chemical property is any characteristic that describes a substance's ability to change into a different substance. For example, flammability. Flammability is a chemical property because if something catches on fire, it's going to burn, and the process of burning turns whatever substance that is into two new substances. For example, photosynthesis and its opposite reaction, cellular respiration, that's sort of a flammability reaction. So if you have glucose that your body has made and you want to use it to make energy, you're going to breathe in oxygen, and that oxygen and glucose are going to sort of, in your own body's terms, it's going to burn, and it's going to make CO2 and water. So whether something is flammable or not, whether it can burn or not, is an ability to turn into a different substance. Water is not flammable. You cannot set water on fire and turn it into something else. Reactivity, so maybe chemical reactivity. Some atoms are very reactive in oxygen and water. That's a chemical property. Flavor is also a chemical property because it's actually a chemical reaction between your taste buds and your tongue and the molecules in your nose that smell. And so whether something has a flavor or what type of flavor it is actually a chemical property. Physical properties are characteristics that are not related to a substance's ability to turn into a different substance. So for example, the density of a substance, whether something is very dense or less dense, is not a chemical property because that doesn't have anything to do with it turning into a new substance. Magnetism. If you have a magnet and you stick it to a nail, for example, you go out to the hardware store and you stick a magnet to a nail, it's not going to turn the magnet into a new substance, and it's not going to turn the nail into a new substance. Malleability is the ability to bend and roll and make something flexible. So wires. So a copper wire is malleable. When you bend and roll and make that wire turn into, coil it up, for example, that does not change the copper into a different substance. So that is a physical property that would describe, for example, copper. Matter can also undergo physical and chemical changes. And there are two types of changes. Again, that's physical and chemical change. A chemical change is a change that transforms the substance into one or more different substances. So we already talked about the example of burning, like cellular respiration. If something gets rusty or tarnishes, that is turning into a new substance. For example, if you have a nail or your bike and you leave it outside for a long time, the outer coating of it will react with the oxygen in the air and it will oxidize or rust or tarnish is another word for rust, and it will turn into a oxide of that metal. So for example, an iron nail will turn into iron oxide, and that's the brown sort of powdery stuff you feel on the outside of something rusted. So that is a chemical change. Most of the time, cooking is also a chemical change because you are altering the proteins and the fats in whatever substance you are cooking and turning them into something different. So these are all examples of chemical changes, or changes that transform the molecules in a substance into different kinds of molecules. When matter undergoes a chemical change, both the chemical and physical properties of the substance are going to change, and that's because the identity of the substance is going to change. So for example, in the idea of an iron nail getting rusty, when it gets rusty, the chemical properties, as in say for example whether that iron will then can get rusty again, that's going to change because the iron that has oxidized and become iron oxide, it doesn't get rusty anymore. It's already rusted. It won't absorb any more oxygen. So that chemical property has changed. A rusty nail, the rust, then that is now iron oxide, is also not magnetic. So magnetism is a physical property, and that has changed when the iron rusted. And so the identity also has changed because the iron in the nail, once it rusts, is no longer iron, it's now iron oxide. So in a chemical change, you're going to see changes in the physical properties, the chemical properties, and also the identity because it's turned into a new molecule. In a physical change, it's almost the opposite. In a physical change, a change in one or more physical properties may change, but it does not change the identity of the substance. So for example, something melting. If you have water that melts, water molecules are H2O. When they're in the solid form of ice, they're H2O. When they melt into a liquid glass of water, it's still H2O. So the physical properties have changed. So for example, physical properties of ice are that it's very hard, it's brittle, it floats in water. When it melts into water, water is not hard, it is not brittle, it is a liquid. And so the physical properties of the H2O molecules have changed when it's gone from ice to water, but it doesn't change the fact that it's made out of H2O. The bonds between the hydrogen and oxygen didn't break. So when matter undergoes a physical change, only the physical properties are going to change. The chemical properties never change because it is still the same substance. So at the molecular level, the molecules that make up that substance have not changed into something different. So here's a picture of melting. Here you can see a collection of water molecules. These little Mickey Mouse shaped molecules are H2O. And you can see that in the solid form, this is an example of what it would look like if we were to look at ice under some sort of a microscope. If you could see the molecules, they would be all nicely arranged in these neat rows, stacked one on top of another. When they melt, they become all disorganized and they're not oriented in the same direction. But we can see that they're still Mickey Mouse shaped. They're still the two hydrogens bonded to an oxygen. So going from the solid form to the liquid form, all we're doing is we're changing the physical properties of the ice cube, and we're moving, basically all that's happening is that the water molecules are moving farther apart from one another. So it is a physical change because the identity of the molecule as water, or H2O, has not changed, and that means that the chemical properties of H2O have not changed. Now if we took that H2O and we put it through a device that would what's called electrolysis of water, here we can see that if we start with H2O, it's going to get broken up into O2 molecules and H2 molecules. So the electrolysis of water, as an example, is a chemical change because the identity of the molecule as H2O is changing. It gets changed into two new substances. And these new substances have new physical properties and new chemical properties. So for example, while H2O in a large quantity could be a liquid, H2 and O2 at the same temperature are going to be gases. So that's a different physical property. So as practice, you could look at, for example, some copper. Copper can be used to make a tea kettle. You can have copper that's melted into ingots, copper wire, copper pipe. Copper can be used for lots of things. The Statue of Liberty is actually made of copper. So you can think about what you know about all of these items, and you could fill in a chart about what are some physical properties and some physical changes and chemical properties and chemical changes of copper. And some examples would be copper is sort of a reddish gold color. It's malleable. It's ductile, which means it can be stretched out. It conducts electricity, which is why it's excellent as copper wiring. And it can also conduct heat, which makes it obviously a good use for the tea kettle. And so physical changes are that you could bend it into a pipe. You could stretch it into a wire. And it also melts when you heat it up and hardens when it cools down. So you can turn it into pennies, for example. So those are all useful physical properties of copper. Some chemical properties that you probably don't know about since you haven't taken chemistry, but copper can tarnish. And again, tarnish is another word for rust. That's why the Statue of Liberty is green, because it is tarnished. It has reacted with the oxygen around it. The Statue of Liberty, it's hard to imagine it, but it was originally copper colored, originally the color of a penny, and we're so used to it being green now. Copper can also be corroded. It can react with acid, so those are properties of it. Now, if it actually undergoes any of those reactions, then that would be a chemical change. So copper has the property that it can tarnish. If it does in fact tarnish to become green, that is a chemical change that the copper has undergone. Copper has the property that it can react with an acid. If it does in fact react with acid, that will be a chemical change because it will have turned the copper into a new substance. Now, if we have a mixture, we can use these properties to our advantage to separate them. So there are two main techniques we're going to cover for separating a mixture. One of which is called distillation, the other is filtration, but there's lots of others. So in distillation, you are going to heat a mixture until one of the substances boils out of the other. This is useful because different liquids, for example, have different boiling points, meaning they boil at different temperatures. Or if you have a mixture of something that evaporates and something that does not, then you can separate those by heating them until the one substance evaporates out, and then you can collect it. Filtration is using a filter and a funnel. Here we have a chemical distillation setup, and we have what we're looking at is salt water. So if you have salt water, that's salt dissolved in water to make a solution or a homogeneous mixture, and you want to get the salt and the water to separate. So some properties of salt and water that are useful is that water boils at a pretty low boiling point, and the salt will not boil and evaporate when the water evaporates. Water also has the property that when it cools off, it will condense back into steam. So if we have the salt water mixture here and we heat it, the steam of just the water, not the salt, the water steam is going to go up into this flask, and it'll then go down this tube and cool off, and it'll drip into here where we now have the pure water. And the salt is going to remain in the solution. So over time you will then have salt left over, and all of the water will have condensed into this flask, and you will have the pure water. Distillation is often frequently used to make perfume as well. If you have flowers, for example, roses, and you press the rose petals to get the oils out of the rose, you can then use other oils to do this, and you can also use water to do this. But if you want to separate the rose oils to have just purified oil, you can then do distillation, and the oil is going to boil at a much lower point than the water or the alcohol or whatever else is used in the process of making the rose petals release their oils, and so you will be left with a purified rose oil. Filtration is a good way of separating maybe two different kinds of solids or a liquid and a solid. And in filtration, you're basically going to use some sort of a funnel or a sieve to separate things based on their size. So you will be left over with the sand that will get stuck in the filter paper because it is too large to move, and the purified liquid.